Good morning to all of you, my dear students. Today, total summary on Unit 2. Last class, we discussed about the filters and analog signal condition. So now, from that point, that is analog signal condition topic, the unit ends. And then this today, that is today's topic is completely summary on Unit 2. So now, this total complete class, the discussion. So now any one of you, you have to give a brief discussion on Unit 2. What we discussed, what are the important points we discussed. First, I will left over to you. So anybody can, right? Anybody can come forward. What are the topics we discussed? So in the chat box, Okay, right. Number 320 lateral entry. I will unmute you. You just you can talk. 320 lateral entry. Yes.
Sir.
Speak out, Babu. Number Banu Prakash, number 320 lateral entry. Can speak out. Speak out.
In Unit 2, we discussed about PN junction diode, PN junction and biasing, and
right, very good.
bipolar junction transistors.
Right, very good.
And NPN transistor.
Right, NPN transistor, correct.
PNP transistor.
Right, very good.
MOSFET, sir, metal oxide semiconductor field effect transistors.
Right, very good.
MOSFET.
Right, very good. Next.
And we discussed about FIT, sir.
Right, okay.
Junction FITs.
Junction, field effect transistor, okay.
And diac and triac.
Right, very good.
And diac characteristics and triac characteristics.
Okay, right, very good.
And next. The JFET and LEDs.
LED, light emitting diode, correct.
P channel JFET and N channel JFET.
Okay, okay.
And operational amplifiers and inverters.
Right.
And differential amplifiers.
Okay, right.
Differentiators, integrating
right,
amplifiers.
Right.
And buffer amplifiers.
Right. Next.
And filters and filters and signal conditioning.
Right, very good, Banu Prakash. What are all the topics in the Unit 2 we discussed? Right, very good. So why we discussed all the things in Unit 2? In the last class, I clearly mentioned. So Unit 2 and Unit 2, Unit 1 and Unit 2, right? So relation. Last class you came?
Yes, sir.
Then why we discussed all these diodes, transistors, amplifiers, filters, switches, various switches, that is a diac, triac, LED. Babu, Banu Prakash?
Yes, sir.
Can you tell? So in the mechatronics, in the first unit, what we discussed, a mechanical system is there. In that, sensors and transducers are there. The output from the transducer we have to give to the signal conditioning, right?
Yes, sir.
So the signal conditioning output here it is nothing but a display or monitor indicating device. So here in the signal conditioning, what are the components here? A to D converters, filters, amplifiers,
Yes, sir.
diodes, transistors, or resistors. So these are all, it is making the signal correct, right?
Yes, sir.
From a mechanical system, here the sensors and transducers are there. This is sensors and transducer, it detect the physical variable, right? And then it converted into electrical form. That electrical signal is sending to the signal conditioning unit. In that signal conditioning unit, what are the elements according to the fundamentals you can use? That is, for example, you need the amplifier, or you need a filter, or you need a field effect transistor, like that. So we can make the signal making correct, right signals. We are making into a right signal. That means we can use amplifiers. If the signal is too noisy, then we can use filters, like that, right? Okay. Next, anyone? Uh, okay, Banu Prakash. Thanks, Banu Prakash. Next, number 336. 336. Regular 336 is there. Regular 336. Mute. Unmute yourself. 336. Nagaraj is there. Nagaraj number 8380. Nagaraj. $380. Nagaraj. Nagaraj, better you post in the group that all of you join. So because of the first 5 minutes or 10 minutes delay, some of the students better you have to post a message, Nagaraju, such that all will be joined. Number 36. What is your name, Nana? 36. Speak out. 36. Nana, what is your name? 36. 36. Number 36. What is your name? Number 36.
చెప్పరా హలో
And the next, number 22, regular 22. Unmute yourself, number regular 22. Regular 22. Fast, don't waste the time. This is completely discussion class. Regular 22. Whether you are there or not, just post a message in the chat box. Number 22, Amma. Number 22. I am putting him in the waiting room. Number 22. Number 23. 23. 23. Just to speak out, Amma. What we discussed, just I will unmute you. 323. Speak out.
Good morning, sir. We discussed in Unit 3 about solid state electronic devices like PN junction diodes, BJT,
Okay.
FET, diac, triacs, and LEDs, sir. And analog
Okay.
signal conditioning and operational amplifier, sir.
Right.
First,
In operational amplifier, what we discussed?
operational amplifiers, we discussed about inverters, sir. Inverters, differential amplifiers. Next,
Right, very
integrating
good.
amplifier.
Right, very good.
Next, buffer amplifier, it is follower, sir.
Okay, and then next one thing, for amplifier, operational amplifier, how many pins are there?
4 pins, sir. Total,
Right. One
four
side
pins,
4 pins, correct?
One side 4, one side 4, sir.
Right. Total how many pins?
Total 8 pins, sir. 4 are
Right.
inputs and 4 outputs.
Very good, Nana. Very good, Amma. Number ante perem peramma ni peru?
Yashwant, sir.
Yashwant, number 23 kadamma?
Yes, sir.
23 kada Nana number? Right. Very good, Nana. Very good.
Yes, sir.
Keep it up.
Thank you, sir.
Right. Very good. Number 36. Number 36. Baba mute gamma. Number 36. Mute. Unmute yourself.
Sir, minute అవ్వట్లేదు సార్.
ఇప్పుడు అవుతుందా? Right.
అయ్యింది
Right.
సార్.
It is audible to me. So just 5 minutes back I asked you, but you are not there. What
సార్
is
అది
the
ఇంట్లో ప్రాబ్లం సార్.
what problems?
బీటెక్ సార్. బీటెక్ గురించి సార్.
ఏంటన్నా?
బీటెక్ గురించి సార్.
బీటెక్ గురించే. ఏం పేరు నీ పేరు?
ప్రణీత్ సార్.
ఏం ప్రాబ్లమ్స్ అన్నా బీటెక్ గురించి?
ఏం లేదు సార్, అదే సబ్జెక్టుల గురించి సార్. అదే కొంచెం ప్రెషర్ ఎక్కువ ఉంది సార్ ఇంట్లో.
మరి కష్టపడి చదువుకోవాలి కదా నాన్న.
అవును సార్.
కష్టపడి చదువుకుంటే ఆ ప్రెషర్ ఉండదు కదమ్మా. అప్పుడు మీ యొక్క పిల్లల్లో, మీ యొక్క ఏజ్ లో యూ హ్యావ్ టు వర్క్ అరౌండ్ 4-5 hours 6 hours per day యూ హ్యావ్ టు స్టడీ. రాత్రిపూట 12 గంటల దాకా చదువుకోవాలి. చదువుకుంటే మీకు మంచి ఫలితం ఉంటుంది. ఎంత కష్టపడితే అంత ఫలితం మీకు ఉంటుంది బాబు. సో డోంట్ వేస్ట్ ద టైం. ఇప్పుడు ఇంట్లో పేరెంట్స్ ప్రెజర్ చేస్తున్నారంటే నువ్వు బాధపడకూడదు. వాళ్ళు నీ మీద హోప్స్, దే ఆర్ పుట్టింగ్ మచ్ మోర్ హోప్స్ ఆన్ యూ. మా పిల్లోడు చదువుకుంటాడు, కష్టపడి చదువుకుంటాడు, మంచి ఉద్యోగం చేస్తాడని వాళ్ళకి ఒక ఆశ. నువ్వు వాళ్ళ యొక్క హోప్స్ ని యూ హ్యావ్ టు ఫుల్ఫిల్ ఇట్. దట్ ఈస్ యువర్ రెస్పాన్సిబిలిటీ. ఓకే. ప్రెషర్ పెడుతున్నాడని నువ్వు బాధపడకూడదు. దానికి పట్టుదలగా నువ్వేం చేయాలి? కష్టపడి చదువుకొని అన్ని సబ్జెక్టులు రాసి ఫెయిల్ కాకుండా పాస్ కావాలి. ఓకేనా?
ఓకే సార్.
మళ్ళీ ఫెయిల్ కాకూడదు.
అవును సార్.
అది గుర్తుపెట్టుకో. ఫెయిల్ కాకుండా నువ్వు జాగ్రత్తగా ఏ క్వశ్చన్స్ నేర్చుకుంటే మనం పాస్ అవుతాము, ఏ ఇంపార్టెంట్ టాపిక్స్ నేర్చుకుంటే పాస్ అవుతాము. మీకు ఏదన్నా కావాలంటే యూ కెన్ ఆస్క్ మీ. నీకు ఏదన్నా హెల్ప్ చేస్తాను నేను. ఓకేనా బాబు? డోంట్ ఇంట్లో ప్రెషర్ ఉంది అని బాధపడాల్సిన అవసరం లేదు. ఎందుకంటే అందరు ఇప్పుడు కష్టపడి చదివే వాళ్ళే అందరూ. అర్థమైందే? నువ్వు కూడా కష్టపడగలవు, పాస్ కాగలవు చదువుకొని. అర్థమైందే?
అవును సార్.
పేరేం పేరమ్మా?
ప్రణీత్ సార్.
ప్రణీత్, బాగా చదువుకోవాలమ్మా.
ఓకే సార్.
సరేనా? ఇంట్లో పేరెంట్స్ చెప్పిన మాట వినాలి. సరేనా? ఓకే. నెంబర్ 35, రెగ్యులర్ 35.
Yes, sir.
What is your name, amma?
Veerbabu, sir.
Veerbabu. Okay, right. In Unit 2, what we discussed, just to summarize, what are the topics we discussed in Unit 2?
Hello.
Cheppam Nana. 35. Veerbabu, cheppamma. వీరబాబు
ఎస్ సార్.
చెప్పు నాన్న. ఎస్ సార్ అంటున్నావు కానీ చెప్పట్లేదు ఏమి.
సార్ 2 days నుంచి నేను క్లాస్ సరిగ్గా రాలేదు సార్.
సరేనమ్మా, మనకి దాదాపు 8 days నుంచి వీఆర్ డిస్కసింగ్ ఆన్ యూనిట్ 2. సో లీవ్ ఇట్ 2 classes and the before classes what we discussed.
జస్ట్ చెకింగ్ సార్.
Okay.
Sir, if you give me time, I will tell you by the end of the class, sir.
Okay, right, Mr. Babu. Okay. Then next, my advice to all of you. So if the class your option is, then already in LMS we are uploading the videos session what we discussed in the class. So you have to better go and then you have to listen the class as and when you require, anytime, even in the examination point of view also, before the examination point of view also, you can go and watch the video, whatever the topic you need, whatever the otherwise, for example, in some particular topic you are absent. So in the evening itself also, you are according to your convenient time, you can watch the video. So this is my advice to you. So you have to use the facility available in the LMS. Correct? Clear? So don't waste the time. You have to concentrate full on studies. So in this particular time only, you have to learn much more in these holidays. So we are taking only 3 classes, right, per day. So the remaining time, plenty of time is there. You have to utilize it. So don't waste that time. Once if you waste the time, it will not return back. So remember this point. The next, I will go now. I will discuss all the summaries. Just I will summarize the unit 2 one by one. In the unit 2, it's completely we discussed about the solid state electronic devices. In the solid state electronic devices, so PN junction diode, BJT bipolar junction transistor, FET field effect transistor, diac, triac, and light emitting diode, analog signal conditioning, operational amplifiers, noise reduction, and also filters. The PN junction diode, it is nothing but P type and N type semiconductor sandwiched together and then forming a diode. So here this is the N type material and this is the P type material. All of you know that N type material having electrons and P type material having holes. That is a positive charge. Right. And this is N type example, N type semiconductor. And see here in this, if you see clearly, arsenic is the donors. So here silicon and arsenic plus, right? Arsenic is the donor and silicon is that it can receive. That means here the arsenic excess of so arsenic can donate. And the next P type. In P type, if you see clearly, it is a boron. Here the boron P type, silicon, that is a boron, it accepts. It accepts. That means here the silicon is the donor here. And PN junction, in this we discussed about the forward bias and the reverse bias. In the here the forward bias, it allows a current from P to N, and whereas the reverse bias, no current allowed from N to P. That means here the current is allowed. Here the negligible amount of current in terms of milliampere, that means 10 to the power of -3 or 10 to the power of -6. Very negligible amount of current is flowing. That means it indicates the electrons are very less, holes are more. That means the holes are dominating in this reverse bias. And then next, I will discuss briefly. The PN junction diode, all of you see clearly, the P-type semiconductor is connected to the positive terminal and N-type is connected to the negative terminal. So here the P-type is holes, that is a positive charge. And here in between P-type and N-type semiconductor is sandwiched. And this region, see here, this region, if you see clearly, this region is the barrier, depletion region. This is the barrier, original barrier. See here, once P-type is holes and N-type is this P-type holes is attracted towards N-type. P-type holes is attracted towards N-type. So thereby the depletion region, see here the original barrier, this is and depletion region decreases. So thereby the current flow takes place. That means in the PN junction diode, the majority carriers are electrons. So once the depletion ratio decreases, then automatically the current flows. So that means in PN junction diode, the majority carriers are electrons. The next, this is the PN junction biasing. See here, if you clearly observe, this P-type is connected to the negative and N-type is connected to the positive, right? So 1 minute. Here, this is NP junction. This is the reverse biasing. PN junction, this is a reverse bias. In the previous, we discussed it is a forward bias. This is forward bias. And this is the reverse bias. See here, in the, what is the difference between the forward bias and reverse bias? P-type is connected to the positive terminal, whereas in the reverse bias, P-type is connected to the negative terminal. Or otherwise, this should be the same terminals, but we can use a NP. We can, this side is N and P. We can go for any way, alternate. And then here in the reverse bias, P-type is connected to the negative terminal and N-type is connected to the positive terminal. See here, this negative is connected to the holes, that is positive charge. That means here some of the, that is, here holes is moves in this direction and negative N-type semiconductor is connected to the positive. This is a negative and this is positive. So direction. In this direction. That means here this is the original barrier. So here the depletion region increases. Why? Because the holes will move in this direction and negative will move in this direction. Because it is the terminals are connected. This N-type is connected to the positive and P-type is connected to the negative, right? So here this is the original barrier. Here the depletion region increases. Here the depletion region increases means the current flow automatically decreases. That means the majority carriers are holes. In the reverse bias, the majority carriers are holes. Of course, the current passes. It's a very negligible amount of current. That is in terms of milliamperes. The next, this is the forward and the reverse bias characters. So see here in the forward bias and reverse bias. Here, when the supply, the positive supply voltage is given to the PN junction diode, then automatically the current increases in the forward bias. Whereas in the case of the reverse bias, see here, at one particular point of increasing of the negative supply voltage, automatically there is a breakdown occurs. Then the voltage remains constant. For particular voltage, the current increases, negative current increases. So that is the reverse bias. And the next, right, next. So a diode is nothing but it consists of two terminals, that is positive, two terminals, P and N type, which is connected to the terminals. And then here this PN junction diode is used mainly for regulating the voltage. regulating the voltage. And so this is the symbol of the diode. This is the symbol of the diode, PN junction diode, right? And the next we will go for the next one. Right. The next, we discussed about the bipolar junction transistor. A bipolar junction transistor. So this is the transistor. Here, this is actually, see here, so this is the shape of the, this is actually the original transistor. So actually this many technology in advance, that is in 1947, Bardeen and Bratton and Shockley, right? These are the two members, these are the three members, Shockley, right? Bardeen, Bratton and Shockley, this transistor is invented. This can be useful as a switch and also as an amplifier also we can use this one, right? This is made of doped silicon. Almost all this now the current transistor are made up of doped. Doped means impurity. The next, this is a bipolar junction transistor, and this see here NPN transistor is there, PNP transistor. PN junction diode is 2 terminals, but here transistor 3 terminals. See here, base, collector, and emitter. These are the 3 terminals. So here the NPN transistor as well as PNP transistor is there. So right. And then in NPN transistor, just I will give you the brief introduction. In the NPN transistor, that is bipolar junction transistor. See here, this N is emitter and P is base, and N-type again it is collector, right? So here in this, the emitter current flows towards the P-type. Here the P-type is lightly doped, or it is because it is a very thin, having lightly doped. So only 5% of the electrons from the N-type is attracted, and the remaining 95% is crosses towards the collector, N-type collector, N-type collector. So that means the emitter current is nothing but sum of the base current and the collector current. So now it is clear. So here in this NPN transistor, the majority carriers are electrons. See here, this one acts as a, see here, this is acts as a forward bias, and this acts as a reverse bias. This acts as a reverse bias. So this one is, right, this acts as a reverse bias and this acts as a forward bias. Yeah, working principle same as that of the diode, right? And the next, we will discuss PNP transistor. In the PNP transistor, same. Here, the P-type semiconductor, P-type, right? That is a positive, the holes. here the holes is passing towards N. Here the N type is lightly doped thin material. Only 5% of holes attracted towards N type because it is electrons. And the remaining 95% of holes will pass us towards the collector region of P type. So the emitter current here is also same. It is equal to the sum of the this N type base current and the P type, that is collector current, base current and collector current. But here it is the holes or the majority carrier. That means positive charge. Whereas in the case of the NPN, majority carriers are electrons, whereas in the PNP, the majority carriers are holes. Here the current is passing, but is a negligible amount of current. According to our requirement, we can use either NPN or PNP transistor, depending upon the current usage. And these are the various types of the transistors, BJT, right? The next, we'll go for the next one. See here, and this is next we discussed about the metal oxide semiconductor field effect transistor. Metal oxide, this is silicon dioxide, SiO2. Metal oxide semiconductor field effect transistor. This metal oxide acts as a dielectric metal, that is silicon dioxide. Usually the FET, it's having same here also, same as that of the transistor. In this FET is also 3 terminals, the named as a gate, source and drain. Whereas in the transistor, emitter, base and collector. Here in this gate, source, drain. Here the gate is the common terminal for both source and drain. Whereas in that, base is the common terminal for both emitter and collector. Right. And if you see this MOSFET, that is metal oxide semiconductor field, this is the construction. If you see, this is a gate, here the gate, and here the oxide layer is deposited on N channel MOSFET on the left side, and on the right side, a P substrate is there, the P type semiconductor. And this is a N type, and this is the gate. In between these two plates, oxide layer is there, that is the dielectric. So this is the plate, the gate, and gate is the plate, and the N channel, this is the plate. So here, so in between these two plates, oxide layer is there, dielectric, silicon dioxide. So this acts as a capacitor. This is the symbol. This is the symbol, right? The next, we can go for depletion mode. Depletion modes here, the gate to source voltage, that is negative supply of the gate is connected to the gate. Here the negative gate to source voltage increases. That is what happened. This side is a negative. This side is the negative. And the other side, it develops positive. That means because this acts as a capacitor. So, and the positive terminal is connected to this. So positive charge is developing more in this case. So total, the current is depleted. Here the positive charge is developing. So here, if you clearly observe, when the negative gate to source voltage is applied to the terminal of gate, that is a gate plate, on the other side, this is a minus, on the other side, positive is developing. That means here, if in the positive gate to source voltage is connected to the source, that is also positive. Here in the both directions, the positive charge is developing more. So thereby the current is depleted. The negative charge is depleted. So here the current passes is very less. So here, so that's why it's called a depletion mode. Depletion means here the current is depleted. Here the positive charge developing is more in this case. So the current is a depletion. So it is called a depletion mode. The next, if you go for the next one. enhancement mode. In this enhancement mode, see here, the positive is connected to the gate. This side is positive. So automatically the other side negative develops, right? On the other side, this is also N channel, the negative charge develops. So here the positive gate to source voltage is supplied to the gate. Thereby the negative charge develops more. That means the current is enhances. The current increases. See, if you see it here, this negative terminal is connected to the source. Here also the negative charge develops. So that means negative charge develops, the electrons develops, thereby the current increases. So that's why it is called enhancement mode. In this mode, the current increases. Current increases, right? The next we'll go for the characteristic drain characteristic. Here, this is a drain to source voltage and this is a drain current. Here the VGS is equal to 0. So when the VGS, that is the negative gate to source voltage, if you give negative to gate source voltage, comes under depletion mode. If you give positive gate to source voltage, this is enhancement mode. That means if the drain to source voltage increases, this gate to source voltage increases, and then thereby the drain current is constant. This is enhancement. And in the transfer characteristics, see here, this is x-axis is the gate to source voltage, and y-axis is a drain current. That means current. Here, if you see clearly, this VGS, see here, VGS is a negative gate to source voltage. Here 0, and this is a negative gate to source voltage. This completely, when you supply negative gate to source voltage, this is coming under depletion mode. And if this is a positive gate to source voltage is given, this is coming under enhancement mode. So here, if you at this point, from this point, the enhancement mode is the drain current. See here, the drain current increases. When the positive gate to source voltage increases, the drain current increases gradually. The current increases gradually. In the negative gate to source voltage, this is a depletion mode. So once the negative gate source voltage increases, what happens? The drain current is there, but it is a very less, right? So negligible current. The next, right. Next. Diac and triac. Diac. So diac and triac both are switches only. See here, a diac, it is nothing but it is a semiconductor device, 3 layers and 2 junctions. Here, having these are the 3 layers, PNP, and 2 junctions. These are the 2 junctions. See here, this is a junction 1 and this is the junction 2. J1 and J2, right? J1 and J2. These are the 2 junctions. That means this is having 3 layers and 2 junctions, J1 and J2. So this is in the diac is nothing but if you see clearly observe, you are having a diode, and this is also a diode. That means 2 diodes, one is forward and another one is reverse. See, the di means a diode. We can also go for tri, quadra, pentra diode also. The diode for alternating current, right? This is the symbol of the diac. And then the diac characteristics, if you observe clearly, see here, when the forward voltage is, that means positive voltage is given to the diac. If you see, this is the forward voltage given to the diac, and then this current, only negligible amount of current increases. And see here, at one particular point, see here, the voltage here, the current is increases. There is gradual increases. See here, it increases. See here. This is at this, from this point we can call it as a forward breakdown voltage. Same similarly in the reverse bias also. If you see clearly, when the negative supply voltage increases, From this point, there will be a breakdown occurs, and thereby the negative current increases by for a small change in the voltage. For a small change in the voltage, there will be a large increase in the current. And then go for next triac. This is the triac, right? In the triac, see here in the triac, same similarly, it is also having in the diac 2 terminals and 3 layers, 2 junctions. But in the triac, see here 3 terminals, that is main terminal 1 and main terminal 2, and also gate. Here the gate is the common terminal, right? Here the main terminal 1 and main terminal 2. So this is a diac and a triac, and these are all coming under the thyristor family, silicon controlled rectifier. See here in the triac, if you go for triac characteristics, clearly when the positive voltage supplies at here, what we are going to see here, see here, the gate is triggered on. If the gate is not triggered on, it is in off condition. That means off condition means there is no increase in the current. There is no increase in the current. See here, if the gate is not triggered on, see here, if you see this arrow mark is gate is triggered on. If gate is not triggered on, see here, this is completely in off condition. Off condition. There is no supply of current. So when the gate is triggered on, the current increases. This is on state. See here, the gate is not triggered on, it is in off state. Right? And then if you see in the reverse bias, when the negative gate to source voltage increases, see here, this is also at here, the gate is triggered on. Once the gate is triggered on, conduction takes place. That means the electrons will flow. So thereby the current increases. The gate is not, if it is not triggered, that is in off. That means the current, there is no flow of current. See, at this point only it breaks. The current breaks. Right, see here. This diac and triac mainly useful for switches, current controlling devices. Right, next. Next we will go for the next one. All right, JFET and LED light emitting diode. JFET, same junction field effect transistor. So same here, source, gate, drain, same as that of the transistor, versus that of the transistor, right? Same, this is a N channel FET, JFET, P channel JFET. And in the P channel JFET, this is increased, the P channel increases. Here, that means here the voltage, if the positive, see here, the positive gate bias, voltage is increased, the resistance of the P channel increases, decreasing the current flow. The P channel JFET, the current flow decreases. That means the holes are the majority carriers. The N channel JFET, majority carriers are electrons. There is a flow of electrons. So now we come to the light emitting diode. So time is over. Just I will take only 5 minutes. Then we can end, right? Light emitting diode. This is also acts as a diode. This is a normally diode light emitting. It works as a principle of a PN junction diode in forward bias. PN junction forward bias. That working will coming under in the LED working principle. A light emitting diode. This is the inside light emitting. See here, if you see clearly, these are the terminal pins, and this is the diode, and this is the plastic case, and the light is emitting. The small light is in. This is already we discussed several applications in this case, right? This works as a diode, that is a light emitting diode, works as a work in PN junction, same as PN, the working principle of PN junction diode, forward bias. Forward bias PN. That means the positive voltage increases. That is a positive supply voltage increases automatically. What happens? The current increases. Thereby, what happens? The light is emitting. So that actually, the class I shown animation type. to you. The class next to, so 1 minute. Okay, see here, just 5 minutes, then I will take the attendance. In the next class, we will discuss about the operational amplifiers. In these operational amplifiers, right? This it consists of 2 dozen transistor, 1 dozen resistors, and 1 or 2 capacitors. See here, it consists of 8 pins. So here inverting input and non-inverting input, and 2 negative voltage supply and positive voltage supply, 2 offset null and output, right? So negative, this is inverting and negative inverting input, and positive is nothing but non-inverting input. So this is mainly, see here, if you see clear, high voltage gain means high input impedance and a low output impedance. High input impedance means the resistance is more. The output, the resistance is very less. And these are the several that is application we discussed, the inverter. So here in the inverter, the voltage V naught, the output voltage is proportional to the input voltage. That means negative. That means here the feedback path in the feedback, that means from the output to the input, feedback resistor is connected. And in the adder, here the 3 resistors are there which are connected in parallel, and RF is the feedback resistor. Here it is nothing but in this, the output voltage is the sum of the input voltages of VA, VB, and VC. The next integrating amplifier, we discussed here 1 capacitor and a resistor is there. And the next, if you go see here in this, we discussed a differential amplifier and then differentiator. Here a differentiator in the syllabus one is there, reducing noise, right? In the reducing noise, you can write down differentiator. See here, this op-amp are normally used as a differentiator as they tend to decrease the signal to noise ratio. If you go in the syllabus, one topic is there, so reducing noise. So here if they ask in the syllabus, you can write down the differentiator. Same this diagram you can write down, and then you can write down the differentiator. Remember this point. And also this is also one of the type of the filter. This is also one of the type of the filter. Reducing noise. And buffer amplifier, same. See here, the output voltage is given to the inverting input, same voltage here. Buffer amplifier, so same voltage, nothing but a unity gain. So the unity gain amplifier, or otherwise we can also call it as a voltage follower. Right, next, last one. Filters and analog signal conditioning, we discussed it. In the filters, all of you know that from a signal, some range of frequencies are eliminated or deleted or removed, and the other remaining frequencies from a signal are permitted. That is called filter. So this is, there are four types of filters are there: low pass filter, high pass filter, band pass, and band stop. Here in the low pass filter, only a low range of frequencies from zero will be passed, and the remaining, that is above the cutoff frequency, are eliminated. That is called a low pass filter. You can also call it as a lag network or integrating network. If you see in the high pass filters, see here, only, that is above the cutoff frequency, only the frequencies from a signal above the cutoff frequency will be permitted, and the remaining, that is all the remaining low frequencies from a signal are eliminated. In the band pass, only a certain range of frequencies are permitted, and the other remaining range of frequencies will be eliminated. That is called band pass. That band stop is also only certain band of frequencies from a signal are stopped or rejected, and all other remaining, see here, in this only particular band only will be passed, and the remaining all are rejected. That means only particular band will be rejected, and the other remaining are frequencies of a signal from a signal are passing, are permitted. There is a band stop. Band stop means only a certain band of frequencies from a signal are reject, and all other remaining frequencies from a signal are permitted. So this is called band stop. And see here, for analog signal conditioning, I said that from the input, see here only signal conditioning, only 5 minutes over. In the signal condition, see here, here the signal conditioning is added here, right? See here, this is the signal condition. Here the input from the, that is sensor, detector, and transducer stage. The transducer is converted that signal into electrical form. This will be sent to the signal conditioning. Here the signal conditioning, here it making the signal conditioner, that is making correct, or it making a right, it sends a right signal to, and then in the data presentation unit we can that is monitor or displaying, or it is indicating device. Then these are the necessity. If the signal is too noise, then we can go for signal conditioning. If the signal is too small, usually in the millivolt range, right? And signals may be non-linear, we have to convert into linear. If the signals is analog, we have to convert into digital. If the signals is digital, we have to convert into analog. So these are the process adapted in signal condition. One is protection, and getting right type of signals, and getting correct level of signals, and also manipulation, and also eliminating the noise. These are the products adapted in the signal condition. Next, okay, right? The time is up. Next, for attendance, we have to respond now. The more right, 12:40. I hope so. All are feel hungry. Right. I will take the attendance. We have to respond one by one. So please post in the chat box. Right. Number 1. Right, 4 present 5. 7 present 8. 9. 10. 11. 13, right, 14. 15. 16, 17, 18, 18, 19, 20, right, 15 present, 21, 20 present, as 21, 22, right, 19 present, right, 15, right, 15 present, okay, right, 23, okay, right, 24, 25, 26, 24, 25 absent, 26, right, okay, 28, okay, 27, 27, 29, right, 29, 9 absent, 30 present, okay, 31, 32, 33, 34, 35, 36, 37, 38, 38, 39, 41, 41, 42, 43, 43, 44, 45, 46, 45 absent, 47, 48, 48, 49 present, okay, 50, 52, 54, 54, 55, 55, 56, 54 present, okay, right, 56, 56 present, and 60, right, 61, 61, okay, next, 63, 63, 63, 63 more, 64, 65, 66, 67, 68, 68, 69, all right, 69, 70, 71, 73, 74, 75, 74, 75, 76, 77, 78, 79, 79, 80, 81, 83, 84, 85, 86, 88, 88, 89, 90, 91, 92, right, very good. And lateral entry 1, 2, 3, 2, 3, right, 4, 4, 4, 5, yes, 5, 6, 6, 7, 8, 8, 9, 9, lateral entry 9, 10, 11, 12, 12, 13, okay, right, 14, 15, 16, 17, 18, 19, 19, 20, 21, right, 22, 23, right, 24, 25, 25, 26, right, 27, 28, 28, right, 27 option, 29, 30, 30, 30, 31, 32, 33, 34, 35, 36, 37, 36, 37, 36 option, 38, right, 39, 40, 40, 40, 41, right, 42, 43, right. So just I will read the option keys. 1, 5, 8, 9, 10, 14, 14, 18, 20, 24, 27, 29, 31, 45, 48, 55, 63, 74, 75, 79, lateral entry 1, 9, 14, 19, 22, 25, 27, 30, 36, 40. Anybody else? Number 350. Already given present. 17th batch 50. Already you are present. But 50, and the 79 network problem. Okay. Okay. Next. Anybody? Okay. We'll end the class. Thank you. Thank you all of you.